Hello students, when capacitors are connected in parallel, we are going to find the expression for effective capacitance of three capacitors in parallel. So effective capacitance is also called as equivalent capacitance. Okay, when capacitors are connected in parallel, the expression for effective capacitance. Arriving at that expression is called as derivation. So capacitor, when three capacitors are connected in parallel means, see here, first terminals are connected together and all the second terminals are connected together. So this first terminal is connected to battery positive and all the second terminal which are connected together to the point B, which is connected to battery negative. So let V be the potential of the battery, potential difference across these ends of the battery. Okay. So you are here observing that the positive electrode is connected to A, where all the first terminals are connected, and negative terminal of battery is connected to B, where all the second terminals are connected to B. That means see here, potential difference across these ends of the battery is same as potential difference across these ends A and B. Therefore, potential difference across each capacitor is same. Okay, potential difference across each capacitor is same, which is same as battery potential or voltage across the battery. Now, when these three capacitors are connected to the point A or connected to this positive potential, then what happens? See, all these plates, the first plates of all these capacitors loses some electrons. Okay, electrons of these plates are get attracted towards the positive plate. Okay, so that's why electrons will move like this, and it is passing through this battery and it will be collected on the respected next plate. So some electrons from first plate of first capacitor moves like this and it will be collected on the next second plate of first capacitor. Similarly, some number of electrons from second plate also moves like this and it will be collected on the next plate. Like this, depending on its capacity, different number of electrons are moving like this and collected on the next plate. So this process continues until the potential difference across the ends of the capacitor, across the ends of this plate, is same as battery potential. Is it clear for you? So this process of charging continues. At the end, what happens? Potential difference across the plate is same as battery potential. Okay. So like this, finally we are observing that charge on each capacitor is different. Charge is different, whereas potential difference is same. Out of QCV, C is anyhow different. We have taken three different capacitor of capacity C1, C2 and C3, and when they are connected in parallel, charge on each plate will be different and potential difference is same. So this is same as writing. If you replace these three capacitor by a single capacitor, so the single capacitor whose equivalent capacitance is Cp, when it is connected across same battery of voltage V, then it holds total charge of Q. Okay, it holds total charge of Q and its potential increases by V, same as battery potential. So this single capacitor is called as equivalent capacitor and its capacitance is Cp. So now we need to get the expression for Cp. For that you have to write all the explanation about this diagram first and then you start writing from the different. So whenever you are writing the derivation, so mathematical expression starts from the different. So here out of Q and V, Q is different. So therefore total charge Q is equal to Q1 plus Q2 plus Q3, whereas Q can be written as CV. Here V is common in all three capacitors. So Q is C1V plus C2V plus C3V, and V you can take it outside, which is common, Remaining is C1 plus C2 plus C3. You call this as equation 1. Now, if the combination is replaced by a single capacitor of equivalent capacitance Cp, then for single capacitor we can write Q is equal to Cp into V. Let this equation be, okay, let this be equation 2. Now equating 1 and 2, so Vcp is equal to V into C1 plus C2 plus C3. V is common because both refers to battery voltage, which is common. So cancelling, Cp is equal to C1 plus C2 plus C3. So this is a equation for Cp. Okay. So that means effective capacitance is sum of capacitance of individual capacitors. If there are n identical capacitors, identical means having same value of capacity, let the capacity be C, then we can write Cp is equal to n times C. So here in parallel, Q is different, V is common. So from this expression, it is clear that Cp is sum of capacity of individual capacitor. That means Cp is greater than highest of given capacitance. Okay. So for example, if this is 2, 3, 4. Okay. What is the value of Cp? 2 plus 3 plus 4. That is 2 plus 3 is 5 plus 4 is 9. So here which is highest? 2 plus 3 plus 4 means it is 4 is higher. Then value of Cp is 9, which is greater than 4. Right. So Cp is greater than highest of the given capacitor, right? So like this, here Cp is what? It is a capacitance when 3 capacitors are connected in parallel. So please go through the question properly. Capacitance of parallel plate capacitor is different. When 3 capacitors are connected in parallel is different. Read the question properly before answering. Thanks for watching.